Hello everyone. Today, we're going to learn how to describe the inside of our planet. We'll start simple and build up to more advanced sentences. Get ready to repeat after me. The crust, our planet's outermost shell. The mantle, the massive middle layer. The outer core, the liquid metal layer. The inner core, the solid metal center. Continental crust forms our land masses. Oceanic crust, beneath the ocean floors. Upper mantle, the mantle's top section. Lower mantle, the deeper mantle region. Now, let's build simple sentences. Repeat after me. The crust is relatively thin compared to other layers. The mantle contains most of Earth's volume. The outer core generates Earth's magnetic field. The inner core remains solid despite extreme heat. We live on the continental crust. Oceanic crust is denser than continental crust. What is special about the crust? The crust is the layer where all terrestrial life exists and which forms the foundation for all surface features. Describe the mantle's characteristics. The mantle, which comprises over 80% of Earth's volume, is a solid rock layer that can flow slowly over geological time. What about the core structure? The core consists of two distinct regions, which differ in their physical states, but which are both primarily composed of iron and nickel. Let's replace basic terms with precise scientific vocabulary. Instead of the hard outer layer, let's call it the lithosphere, comprising both the crust and the rigid upper mantle. Instead of the soft mantle layer, we say the athenosphere, a ductile, semi-molten zone in the upper mantle. Instead of the deep mantle, it's more accurate to say the mesosphere, referring to the lower mantle beneath the athenosphere. Instead of the liquid core, let's be specific, the viscous outer core, a turbulent molten metal sphere. Instead of the solid center, let's call it the crystalline inner core, a solid metal ball under immense pressure. Now, let's describe complex geological processes. The Earth's interior is perpetually differentiated by density, creating distinct compositional layers. Thermal convection currents within the mantle gradually drive plate tectonic movements. The outer core's continuous convective motion acts as a planetary geodamic. Heat from radioactive decay provides the thermal energy that sustains these processes over billions of years. Let's make our descriptions pop with some more powerful and precise words. The crust is disproportionately thin compared to Earth's total radius. The mantle is overwhelmingly massive, containing the bulk of Earth's material. The outer core exhibits violently turbulent convection patterns. The inner core exists under almost incomprehensible pressure. Mantle material flows imperceptibly slowly over millions of years. The crust is the outer layer of the Earth. The crust comprises the Earth's outermost layer. The crust forms the Earth's outermost shell. The crust constitutes the Earth's outermost solid region. The mantle is very thick. The mantle is immensely thick. The mantle is exceptionally thick. The mantle comprises the bulk of the Earth's volume. The outer core is made of liquid metal. The outer core is composed predominantly of liquid metal. The outer core consists chiefly of iron and nickel. The outer core is a viscous sphere of molten iron. The inner core is a solid ball. The inner core is a crystallized sphere. The inner core is a monolithic seed at the planet's center. The inner core remains an impenetrable solid. The heat moves the mantle slowly. The heat drives mantle convection. Radioactive decay propels the mantle's motion. The mantle is perpetually churning. The mantle moves at a glacial pace. The outer core creates the Earth's magnetic field. The outer core generates the Earth's magnetic field. Its turning motion gives rise to the magnetosphere. The core dynamically sustains our protective magnetic shield. The crust is not the same everywhere. The crust's thickness varies considerably. The crust is a heterogeneous layer. The oceanic crust is discontinuous at mid-ocean ridges. There is a lot of pressure on the inner core. The inner core withstands immense pressure. It exists under overwhelming pressure. The pressure is astronomical. The pressure is on the order of millions of atmospheres. The layers formed a long time ago. The layers differentiated billions of years ago. The Earth accreted and then differentiated. This occurred in the planet's primordial stage. This is a picture of the Earth's inside. This diagram depicts the Earth's internal structure. The cross-section illustrates the subsurface layers. It provides a schematic of the Earth's interior. The crust is thin. The crust is fragile. The crust is discontinuous. The crust varies considerably in thickness. The mantle is very thick. The mantle is immensely thick. The mantle is exceptionally thick. The mantle comprises the bulk of the Earth's volume. The core is hot. The core is scalding. The core is superheated. The core generates immense thermal energy. The outer core is liquid. The outer core is molten. The outer core is viscous. The outer core churns vigorously. The inner core is solid. The inner core is crystallized. The inner core is impenetrable. The inner core remains solid despite extreme heat. The plates move on the mantle. The plates glide on the mantle. The plates drift on the mantle. The plates shift gradually on the mantle. The mantle has convection currents. The mantle experiences convection currents. The mantle facilitates convection currents. The mantle perpetually churns with convection currents. It's easy to say blue or red, but let's learn more descriptive and precise color words. I'll show you a simple way and then a more advanced way. Repeat after me. The crust is light blue. The crust has a pale blue hue. It's a soft, azure color. The mantle is red. The mantle is a vibrant red. It has a deep, reddish-orange tone. The outer core is yellow. The outer core is bright yellow. It's a luminous, golden yellow. The inner core is white. The inner core is brilliant white. It has a solid, stark white center. See the difference? Using words like pale, vibrant, bright, luminous, and stark makes your description so much more interesting. Now, let's talk about shapes. We won't just say circle. We'll describe the structure. The Earth is a circle. The Earth is depicted as a perfect sphere. It's shown in cross-section. The layers are like an onion. The layers are concentric rings. They form a series of nested shells around the center. The crust is a thin line. The crust is a slender, irregular band. The continental crust is jagged and uneven, while the oceanic crust is a smoother, continuous arc. The mantle is textured with a stippled pattern, suggesting movement. Now, let's combine colors and shapes. I'll ask a question, and we'll answer with a full, descriptive sentence. How would you describe the overall structure of this diagram? It illustrates our planet as a series of concentric circles in a vibrant color palette, ranging from cool blues to warm reds and yellows. Describe the outermost layer. The outermost layer is the crust, which forms a slender, pale blue ring that is irregular and jagged in parts. What about the large middle section? This is the mantle, a thick, deep red band that makes up the bulk of the sphere and features a subtle stippled texture. How would you describe the core? The core consists of two distinct spheres, a bright, luminous yellow outer core and a solid, stark white inner core at the very center. For our final practice, listen to me describe the entire picture. After each sentence, repeat exactly what I say. This diagram presents a striking visual cross-section of our planet. The color scheme is both symbolic and visually effective, using a gradient from cool exterior tones to a hot, fiery center. The entire structure is composed of concentric spherical layers, resembling a cut-open onion. A thin, pale blue and irregular arc represents the Earth's fragile crust. Beneath it lies the vast, deep red mantle, which is textured with a subtle dot pattern. At the heart, we see the core, a brilliant yellow outer ring surrounding a dense, solid white center. Let's practice collection of phrases for describing the Earth's layers or anything else. Introducing what you're talking about. Let's start by taking a close look at the Earth's internal structure in this cross-section. This diagram really shows how temperature and pressure just keep building as you go deeper. The big idea here is planetary differentiation, how gravity sorted the planet into layers. Pointing out where things are. Right below the crust, you'll find the rigid upper mantle. Together, they form the lithosphere. Sandwiched between the upper mantle and the outer core is the lower mantle. It's actually Earth's most voluminous layer. Surrounding the solid inner core on all sides is the liquid outer core, a unique spherical shell of molten metal. Sitting at the planet's very heart is the inner core, the densest and most compressed region of all. Breaking down the structure. Basically, the Earth is made of these concentric shells, and they get denser the deeper you go. The main parts are the silicate-rich crust and mantle, and the metallic core. We can look at this in two ways: mechanical layers based on how they behave, and compositional layers based on what they're made of. Explaining what things do. The core's main job is to generate Earth's magnetic field through its dynamo action. Mantle convection acts like a conveyor belt, slowly moving Earth's internal heat toward the surface. Plate tectonics is ultimately driven by the slow, relentless churning of the mantle below. Making comparisons. Unlike the brittle lithosphere, the athenosphere is ductile and deformable. Oceanic crust is thin and dense, while continental crust is thick and buoyant. Much like the outer core, the mantle also has large-scale circulation patterns. Making inferences and drawing conclusions. From this structure, we can figure that Earth must have been mostly molten early on. This setup strongly suggests that there's ongoing chemical interaction between the layers at their boundaries. The inescapable conclusion is that Earth's interior is still dynamically active and evolving, moving from one point to the next. As we move down from there, we run into even hotter, denser material. After the crust-mantle boundary, the next big jump is at the core-mantle boundary. Shifting our focus to how the layers behave instead of what they're made of reveals a different pattern. Summarizing the big picture. So, to tie it all together, Earth operates as one big, integrated thermal and mechanical system. The key takeaway is that surface geology, like volcanoes and earthquakes, is ultimately controlled by deep interior processes. In a nutshell, all these elements work together to create a dynamically evolving planet. To sound truly advanced, we need a more nuanced vocabulary. Let's replace simple words with more powerful ones. The crust is not just thin, it is disproportionately thin, a mere fragmental layer compared to the Earth's total radius. The mantle is not just thick, it is overwhelmingly massive, constituting approximately 84% of the Earth's total volume. The outer core is not just liquid, it is a turbulent, convecting sphere of molten metal. The inner core is not just hot, it exists under prodigious pressure and incandescent temperatures, creating a unique solid state. The boundary between the inner and outer core is not just a line, it is a profound phase transition zone from liquid to solid. Now, let's employ powerful verbs and vivid adjectives. We won't just say is, we'll say what it does and how it exists. The crust varies considerably in thickness. It's fragile and comparatively thin. The outer core churns vigorously. This ferrous, molten alloy is fundamentally responsible for our geomagnetic shield. The inner core crystallizes under astronomical pressure. It's an impenetrable, superheated solid sphere. The mark of advanced fluency is seamless linking. We'll use phrases to show contrast, consequence, and addition. The continental crust is relatively thick and light. Conversely, the oceanic crust is significantly denser and thinner. Beneath the rigid lithosphere lies the athenosphere, which, consequently, allows for the lateral movement of tectonic plates. The heat from the core not only drives mantle convection, but also ultimately powers the geodynamic in the outer core. Despite temperatures far exceeding the melting point of iron, the inner core remains solid due to the overwhelmingly high pressure. Furthermore, this entire layered structure progressively formed through the process of planetary differentiation. Let's be specific about scale and proportion. We'll replace a lot with precise quantifiers. The The crust constitutes merely a fraction of Earth's total mass, less than 1%, in fact. The mantle, in stark contrast, accounts for a staggering 84% of Earth's volume. The core is predominantly composed of iron-nickel alloy, with a substantial portion of the outer core existing in a liquid state. The pressure at the inner core is on the order of millions of atmospheres, an almost inconceivable magnitude. Finally, I'll present a complete scientific description. Repeat each sentence after me, focusing on flow and pronunciation. Our planet's internal structure represents one of geology's fundamental concepts, revealing Earth's thermal and compositional evolution. Our planet's internal structure represents one of geology's fundamental concepts, revealing Earth's thermal and compositional evolution. The outermost lithosphere forms a rigid shell that fractures into tectonic plates, which gradually migrate across Earth's surface. The outermost lithosphere forms a rigid shell that fractures into tectonic plates, which gradually migrate across Earth's surface. Underpinning these plates, the athenosphere provides a ductile zone that facilitates plate motion through slow, plastic deformation. Underpinning these plates, the athenosphere provides a ductile zone that facilitates plate motion through slow, plastic deformation. The massive mantle beneath extends nearly halfway to Earth's center, behaving as a solid over short time periods, but flowing viscously over geological eras. The massive mantle beneath extends nearly halfway to Earth's center, behaving as a solid over short time periods, but flowing viscously over geological eras. At the core mantle boundary, we encounter one of Earth's most dramatic transitions, marked by extreme changes in composition and density. At the core mantle boundary, we encounter one of Earth's most dramatic transitions, marked by extreme changes in composition and density. The liquid outer core beneath this boundary churns vigorously, its convective motion generating Earth's extensive magnetic field through dynamo action. The liquid outer core beneath this boundary churns vigorously, its convective motion generating Earth's extensive magnetic field through dynamo action. Finally, at our planet's very heart, the solid inner core represents a crystalline metallic sphere growing slowly as Earth gradually cools. Finally, at our planet's very heart, the solid inner core represents a crystalline metallic sphere growing slowly as Earth gradually cools. This entire layered structure operates as an integrated system, with each zone playing a crucial role in planetary dynamics. This entire layered structure operates as an integrated system, with each zone playing a crucial role in planetary dynamics. Composition: what something is made of, makeup. Rigid, stiff, and not able to be bent easily, stiff. Ductile, able to be deformed without losing strength, malleable. Differentiate, to become different or develop into different forms, separate. Convection, the movement of heat in a liquid or gas, circulatory heat transfer. Disproportionately, to an extent that is too large or small, unequally. Turbulent, moving in a violent, uneven way, chaotic. Incomprehensible, impossible to understand or imagine, unfathomable. Imperceptibly, in a way that is so slight it cannot be seen or felt, unnoticeably. Viscous, having a thick, sticky consistency, thick. Molten, made liquid by extreme heat, liquefied. Predominantly, mostly, mainly, primarily. Chiefly, mainly, mostly, principally. Crystalline, having the structure and form of a crystal, crystal-like. Monolithic, solid, massive, and uniform, massive. Impenetrable, impossible to pass through, solid. Propels, drives or pushes something forward, drives. Churning, moving violently or vigorously, stirring. Heterogeneous, diverse in character or content, varied. Discontinuous, not forming a continuous whole, interrupted. Withstand, to remain undamaged under pressure, resist. Immense, extremely large or great, enormous. Accreted, grew by gradual addition, accumulated. Depicts, shows or represents, illustrates. Fragile, easily broken or damaged, delicate. Scalding, very hot, burning. Superheated, heated to a very high temperature, extremely hot. Vigorously, with great force and energy, forcefully. Drift, to be carried slowly by a current of air or water, float. Facilitates, makes an action or process easier, enables. Perpetually, never-ending or changing, constantly. Hue, a color or shade, color. Vibrant, bright and striking, bright. Luminous, full of or shedding light, bright. Stark, severe, sharp and clear in outline, harsh. Concentric, having a shared center, ringed. Nested, fitted inside another thing of the same kind, stacked. Slender, thin in an elegant or graceful way, thin. Jagged, with rough, sharp points, spiky. Gradient, a gradual change in color or value, shade progression. Fragile, easily broken or damaged, delicate. Convection, the movement of heat within a fluid caused by hotter, less dense material rising and cooler, denser material sinking, heat circulation. Differentiation, the process by which a planet forms distinct layers based on the density of its materials, planetary separation. Geodynamic, relating to the forces and processes within the Earth that cause movement and change, planetary engine. Radioactive decay, the process by which unstable atoms break down, releasing energy in the form of heat. Viscous, having a thick, sticky consistency between a solid and a liquid, flowing slowly, thick fluid. Crystallin, having a regular, repeating atomic structure, like a solid metal or a mineral, crystal-like. Dynamo, a process, like the movement of the liquid outer core, that generates a magnetic field, magnetic generator. Silicate, a mineral containing silicon and oxygen, which the Earth's crust and mantle are mostly made of, rock-forming mineral. Alloy, a mixture of metals, such as the iron and nickel that make up the Earth's core, metal mixture. Deformation, the process of something changing shape due to stress, like the slow bending of rock in the mantle, reshaping. Primordial, relating to the earliest stages of a planet's formation, ancient. Heterogeneous, composed of different kinds of elements, not uniform, varied. Imperceptibly, in a way that is so slow or slight it is almost impossible to detect, unnoticeably.